A number of people said they're having difficulty still on the types of lines. And I'm telling, it's a good, besides, signing up for a time to spend with me going over things, go back and look at class number 2, because I have about 10 sheets in there, and they're all talking about different examples of the types of lines. Some of you are having difficulty on transferring the depth dimension to oblique. And what I decided is from now on, we're only going to concentrate on cavalier oblique. So what does that mean? Why am I saying we're only going to concentrate on cavalier?
You don't have to change the.
You don't have to half the depth. It's the true depth. Okay, so we're only going to concentrate on cavalier from now on. This way you're only transferring the full depth. Okay? I am still seeing issues on quizzes on homeworks of drawing consistent thicknesses of lines and differences between thin and thick. I'm noticing a number of you, when you draw hidden lines, instead of trying to be consistent. So again, here's my thick line, my thick line, my thick line. Here's a thin line, right? Can you see the difference? Some of you are just going like this to draw hidden lines. And then in the end, first it turns out to be too light. And second, they're varying in thickness. They're varying in length. So you want to make sure that you're being consistent. You have to be neat. Okay? So definitely make sure that you can see a difference between the thick and thin, and make sure that you're trying to be consistent in your hidden space, in your hidden lines. And keep the pen down on the paper the whole time. You know what I'm saying? Like you're going like, some of you are going like that to draw hidden lines. And then it's thick here and it's thin here and it's never consistent. It's dark and light. Okay, let me see what other things. A number of you said it's kind of difficult, and it's true, planning out the space on your drawing. So if you want to draw something, it is kind of difficult of figuring out the arrangement on your paper. And you'll get better and better at it, and now that you understand scales a little bit better, think about how am I going to fit this big thing on this 8.5 by 11 paper. It's about spatial, so you have to just try. Need more practice drawing 3D pictorials from multi-views. I see there's an error here. Do more searches on YouTube videos. Once they give you the multi-view, draw it yourself and then finish watching the video. You really just have to practice. And then some of you said you don't have enough time to do homework. And I can understand that. You're all kind of stretched. You're in school taking a bunch of hard classes, you work and life. But you have to be able to manage your time better. Many of you are just starting out. You may not have taken physics yet. You may not have taken chemistry yet. You may not have taken Math 5B or 5C yet. You have to get better in time management. Those of you who took Engineering 5, there was a part that we talked about time management. I don't know. I wrote one suggestion up there. What I notice, I think it's really hard on you guys that you have smartphones and that people can find you all the time, because you're constantly checking your phone. And anytime, Joe McCullough will tell you this, he's a physics teacher, he did a lot of work on brain stuff and learning. Every time you pull yourself away from what you're doing, you're distracting yourself and it takes longer to get back into it. You need time where you're not being distracted. So I don't know, I made a suggestion. Only check your phones once an hour. When you're working on stuff, don't get bogged down with who's calling you, who's texting you, who's phoning you, the emails. I mean, you can get totally bogged down in all this electronic stuff. I see it for me too. When I'm writing a report and I have my phone near me, I wind up just putting the phone away. I shut it off and I don't go to it for an hour so I could get something done. Anyway, that's my suggestion, but I'm sure you guys have suggestions that you've done. So why don't you turn to the person next to you or your group? What things have you done to be able to get your time management skills better? Or what are you realizing that you're doing that's not really that helpful? Okay, ready? Okay, reading. Read through the text. There are really good descriptions. There's some descriptions on scaling and some of the other things you're having issues on. So you get another viewpoint. And then lastly, just come and see me or Karen or Barbara or anybody else who's taken Engineering 25 already. Okay? Okay, so the topic we're going on today is sectional views. So I'm going to go back now to modules. So why don't you push your scales away, all the scale stuff, put all that away, just have your drafting board clear. Pull out the packet. You have 2 sheets of sectional views. So it's the next 2 sheets in the packet after the scales. The next 2 sheets after the scales. Okay, if I have my working set of drawings and I have some part, one part. If I have one part that I want to draw, how many views do I need? 3. So I have my front view, I have my, what is this? The top view or the horizontal, and then this is my side or my profile. And then typically I have an isometric drawing right here. Oh. Showing this. So a set of working drawings for one part. So if you look at your mechanical pencil and you took it apart, there's probably like at least 5 parts in here. And for each one of those parts, you would have to have a front, a top, and a profile, and a 3D drawing. But it was either Andrew or Peter, I think Andrew, it was you who asked like way back, what if these 3 pieces, these multi-views don't really communicate apart because the part is complicated. I had mentioned then is there's times that you draw sectional views, which is showing you what's happening inside the part, or an auxiliary view. Today we're covering sectional views. So let's take a look at some examples of sectional views. So I'm going into today's class, which is class 7, February the 20th, going into sectional class notes. Now I'm going to come back to this sheet. Let's check the light. So first take a look at the picture up top. All the way up top, what is that, an isometric or an oblique? Isometric, right? If we looked at it from the top, we would see this and the front. So for right now, take a look at the 3D part and the top and the front and talk to the person next to you and see if there's any lines missing here. Are there any lines missing? And I guess the other question is, what is all of these visible lines and these hidden lines, what are they communicating in the part? Is there something that the multi-views are showing you that you don't really, that you don't see in the 3D view? Not talk to me, talk to the person next to you.
There's a hole.
But it's not just a hole, it's a little bit of a hole now.
So those sectional views, that's
Showing that inside it when it's
Yeah, it's showing that they
So this hole right here, you can see in the 3D drawing, and you see that it's communicated right here.
No.
I'm sorry, right here,
yeah.
okay? And then it's also communicated here with hidden lines, right? And then this is describing a hole that's on the bottom that you can't see it, right? And then here are the hidden, so it's showing you how it's actually drilled. Those of you who took Engineering 12, this is called a counterbore, right? This one right here, where you're drilling a larger one, there's a sink, a countersink, and then here's a larger hole. What you notice here is that here you see the hole with visible lines, here you see it with hidden lines. But what about this other hole that you could see in the 3D? How is it communicated here? Visible or hidden lines? What about here? Where is it? Here, hidden lines. It's described only with hidden lines. It's very important in multi-views that you have every edge described somewhere in a multi-view with visible lines. If I drew a right side view of this part with this hole that's hidden and hidden here, would it be hidden or visible on the side view? It would be hidden again. Okay? So what did the engineer who drew this, they realized that it wasn't, putting the side view wasn't really going to help because that hole is still going to be shown using hidden lines. So what they decided to do was slice the drawing and only draw an inside view of it, which is called the sectional view. What are these lines called? Do you remember? Is it a viewing line plane or is it a cutting line plane? Why cutting? Because you're actually cutting the part. You're actually taking the part, cutting it, and what do the arrows denote?
Which direction?
Which direction your eyes are looking at it. So they have the top and they have the front, and then they showed the top view and they put a cutting plane line, which really should be a thick line, right? It doesn't look too thick to me here. That has arrows to show. And typically, I'm gonna pull this up. I think Kelly might have had some, no, okay. This really should be labeled. So this cutting plane line should be labeled something. The first sectional view that you draw on any drawings, it's an AA, then a BB, then a CC, and then a DD. So this one should be section AA. Now, when you do cut that, let's bring this back down. When you cut it here, what are you actually physically cutting? What's getting cut? How are you denoting the part that's being cut? These lines, right? Which maybe you might have called them hatch lines before, but we know that they're section lines. And notice the section lines are angled. What angle are they at? 45 degrees, that's standard. Now, is all this cut? No, because that's the back part. you're still seeing it. But what happens now? That hole, it becomes visible. Andrew?
Let's say that the thickness when it's cut, it's not actually solid. Let's say it was like hollow and filled with another material. But it's, how would you represent that? Would you have to do a
A different
separate?
material. So let me go back to the, so is everybody getting the feel, let me answer that question a little bit. Everybody getting a feel for what a sectional view is? When the regular multi-views and a 3D view isn't enough to communicate something, you have to show something else, and a sectional view is one way of doing that. Let's take a look at this. So again, look at the 3D drawing. Here's the top view and the front view. They feel it's more important to show it visible. So they decide where they're gonna put the line, where they're gonna cut the plane, and this is, again, a cutting plane line. And then you're viewing it going in this direction. You guys can move it forward. Okay, let's take a look at some examples that are correct and not correct. So again, we're starting with this 3D view up top. They already sliced it to show you the direction. So this is what it originally looks like, right? This is its original top, and this is its original front. And what do? They put a cutting plane line here and a cutting plane line here. So they're telling you one is correct and one's incorrect. What's the difference between these two? Talk to the person next to you and see if you agree with that rationale.
Yeah, 'cause there's,
It falls down, right when you get to the outer kind of part,
Why is it
that's
not
the
line?
edge right there.
Why don't we have a line? Why does the market not have a line?
Well, because there's not,
Okay, so when,
like those planes are separate from each other, so you need to.
When
put a
you
line
cut-
there, so-
when you cut this surface, when you cut this here, this line right here, this edge becomes a visible edge. And you have to have a visible line in there. Right, because when you're looking at it now, it's clear that this edge should be represented by a line, and here it is. Okay. Let's look at another one. So here, the difference isn't in the sectional view. The sectional views are the same. What's different? Not, right, the arrows of the sectional view. So if I'm cutting it here and I'm viewing it inside, if I'm viewing it inside, I have to have my arrows going that way because that's the direction that I'm viewing it. And I see an L here and a backwards L here. If I actually have it this way, I'm viewing this side, not that side. Does that make sense? If the arrows are here, I'm looking at, so here, I'm cutting it and I'm looking at this piece at the cut. If I have the arrows going down, I'm viewing it this way and I'm looking at this piece at the cut, which is the mirror image of this. So these two together do not go together. These go together. Okay, I'm going to give you another, we'll have an activity today. Let's look at something else. Okay, so here's the object, the 3D object. This is the top view. This is the front view. We have some hidden lines here and here. What they're doing is they're slicing it again, but the plane is a horizontal plane that they're slicing it. So now, the cutting plane line needs to be in the front. This is where I'm taking my knife and slicing it, and I want the viewer to look down, and this is what I'm seeing. So make sure that, looking at that 3D, looking at the direction of this cutting plane line, and make sure you're comfortable with what is drawn. Clara?
If your hidden lines are obscured by visible lines, that means you have to do the sectional view?
Say that again?
Because you do sectional view, so you, like, so you see all, like, hidden lines as object lines?
Yeah, so I wouldn't say that, when hidden lines are obstructed by visible lines, that's not necessarily a reason to draw a sectional view, because in another view, maybe the side view, you could actually see the edge. And then there is, like, maybe in the front view, the visible line is going on top of the hidden, so you can't see it. But then when you look at it from the side, you see where the other edge is. That might not be a reason to do sectional. A lot of the examples I'm showing you are things that are going on inside, and quite often you're noticing there are some kind of holes, right? Because I want to make sure that my machinist is putting the hole in the correct spot. Okay? So, I would never give you a part and say, should you draw a sectional view here? That's really beyond the scope of this class. This is not even, I wouldn't even say it's an undergraduate topic. It's something you're gonna get used to as an engineer and learn when you put sectional views and when you don't. What the skill that you wanna build here is, do you know how to draw a sectional view if you're given the cutting plane line? I'm glad you're asking this question. Did everybody get that? You're not leaving this class with a complete skill on when to do sectional views or when to do auxiliaries. Right now, you're leaving this class knowing how to draw a sectional view if I asked you to draw one. Okay? Yeah?
Do they have to be cut in a single plane?
No, and I'm gonna have one that's offset. Okay, everybody okay with this? Okay, here's just another one. I'm trying to give you different examples of where the cutting plane line is. So here's the front view. Well, actually, I should ask you, what view is this? It's gotta be the front, and this is the top, and what's this?
Section.
That's the section view, that's not the left side view.
Wouldn't that be the depth?
Say it again? It would be the depth. So we have the front and we have the top, and this is where they're cutting the part, and they're looking in that direction. I would actually not put this here, I would put it over here. Because I think it's confusing having it on the left side. But you see what you're cutting out, right? There are two L's that you're cutting out. And then you're getting to see the circle, and you're getting to see that piece.
I mean, isn't it being cut on the profile? Not the-
That's what I wanted you to know. This is not the profile. Tell me what, I'm really glad you asked. That's what I was trying to explain, but I'm glad. This is not the profile. How do you know it's not the profile? Hmm?
It's on the right side of the isometric.
Sexual lines?
What's above it?
The top.
Do you ever put a top view above a profile? Never. So it's gotta be the front view. That was really good that you asked that, because you never put a top view above a profile. You put it above the front view. Okay. Let's see, this is interesting, huh? In this case, notice they labeled it this time. Why didn't they label the sections before?
There's only
Because there's
There was only one cutting plane line, right? But imagine when you're doing drawings and you have a set of drawings on some part, all those multiple parts that you drew, you're gonna have to have it labeled. In this case, they happen to have it. So what is this? What multi-view is this? Front. Okay, and they're showing you BB and AB. You don't see where I guess it's this piece, huh? Yeah, it's the same piece. So when you have two sectional lines, you have to have it labeled. Okay. Now, what did I say the general use line is at, what angle? 45 degrees. I'd have to measure this, but this may be at 45 degrees, but notice what's happening. It's parallel to the visible lines. That's not good practice because somebody could get a little confused. What's better practice is go off a little bit of the 45 degree. And what is this? Why are they saying to avoid this?
Negative slope.
First of all, it's the opposite of what you would ordinarily do. You're always drawing it like this. The other is that it's perpendicular to the sides. So you want to avoid having parallel and perpendicular section lines to visible lines. So when you want to draw a sectional, you typically would want to go off 45 degrees and draw them parallel. What do you think about the spacing between the section lines? It should be consistent, right? It should be consistent. This is where that parallel rule comes in handy. I remember now somebody approached me at the beginning of class and still wants to buy one. That stuff that you have to purchase is back there, so I can pull that out. So make sure the spacing between the section lines is consistent. What's going on here? What are they telling you? And these are ANSI standards. 45 degrees preferred. What's going on here? What do you notice?
The lines are offset from behind the words.
Think of, imagine that you did the section lines first, and then you chose to dimension or put a note. What do you need to do with the section lines? Yeah, you have to erase them in that area. You don't want the notes to go right over the lines. Okay, so then if you know you're gonna dimension or put notes, then you're gonna have to erase this area and then put that in. How about, what do you think this is all about? Well, no, these lines, what do you think these lines are supposed to represent? Section lines. It's just a huge part, and if you put all those lines, it just looks too many lines. It's like when you're gonna print something out that's all black and you're gonna use a lot of ink, you're not gonna print it out on an 8.5 by 11 and use up your whole toner cartridge or your ink, right? You're gonna make it smaller. This is the same kind of thing, but instead, rather than, if you have this huge part, you're not gonna draw all the lines. If you put the lines all around like this is also showing that it's a section. But you only do that when there's a lot of section lines to draw. Okay, so here's an answer to one of your questions. Everybody look at this, and how many parts are here? So talk to the person next to you. How many parts do you have?